Hello students, today we will discuss the interference of the light in wave optics. It begins with interference of light, principle of superposition, constructive interference, destructive interference and condition for steady interference pattern and Young's experiment. Right? Initially, we will discuss the interference of light. Interference of light. What is the interference of light? Interference takes place when the waves interact with each other. These interactions are governed by principle of superposition of waves. Interference effects are exhibited by all wave motion, the brilliant colors of butterfly's wing, thin oil film on water, and peacock feathers are the effect of interference and diffraction of light. Interference means if two or more waves, set of waves are allowed to pass through and cross one another in the same medium, they would behave as if other were no present. That is, the effect produced by one wave would be totally independent of the effect due to other wave. The resultant effect at any point, at any instant of time, is governed by principle of superposition. In this principle of superposition, look at this figure. Here, waves on the water surface. Two drops are there. Waves which are formed, they are interfere with each other. After that, principle of superposition. This principle of superposition, when two or more waves overlap, the resultant displacement at any point, at any instant, is equal to the vector sum of instantaneous displacement that would be produced at the point by the individual waves if each wave is present alone. The modification in the intensity of light produced by the superposition of two or more light waves is called interference of light. So look at this figure. In this figure, two waves are there. In this figure, two waves are there. In this wave, this part that is called as the crest, or this is also crest, and this is trough. These two waves, means this dotted line and this line, these two waves interact with each other and we get the resultant wave, means this one resultant wave. The distance between this first crest and this crest, the distance between these two, that is the path difference. And what is the phase difference? This is the 0, this is the pi, 2 pi, means this is the phase. Means this wave which is in phase means in proper way. And this wave which is out of phase means improper way. This is the crest and trough and resultant waves are there. After that, constructive interference. What is the constructive interference? Suppose there are 2 points A and B on the surface of water, where two exactly similar circular waves are produced by two needles attached to the prong of an electrically maintained tuning fork. This is the ripple tank experiment. These circular waves would travel out in the form of crests and trough on the surface of water surface. Suppose continuous lines present in the crest while dotted lines present through trough. The point at which the crests fall on crest and trough fall on trough are marked by the cross. At such point, the resultant displacement is maximum. The waves reinforce each other and the interference is called as constructive interference. While other points where the crests fall upon a trough and vice versa are marked by a circle, these are the points correspond to minimum displacement. Such point on the surface of water remains stationary and resultant effect at these points is called as the destructive interference. look at this figure. In this figure, these are the waves. In this side, circular waves, means waves on water surface. This dotted line, this is the dotted line. Overlap with dotted line, means trough overlap with trough. This normal line, which is overlap to this normal line, means crest overlap with crest. Means trough overlap with trough and crest overlap with crest overlap with crest and trough overlap with trough. That which is means that time maximum intensity of light is there, means maximum displacement is there. So that time constructive interference. And after that, in this case, dotted line overlap with the normal line. That time crest overlap with trough. That time minimum displacement is there, intensity minimum, which is destructive interference. So look at this figure. Due to interference of two light waves, the redistribution of energy takes place in the medium. The light energy which disappears at the position of minima and appears at the position of maximum. Okay. So next, constructive interference. In this constructive interference, consider the point P. Means point P, this is the point P. Look at this figure, this is the point P. Here, this is the source of light. Means this is the S1, this is S2. Distance between S1 and S2, that is small d. That is the distance between source of light. This source of light and this is the screen. The distance between this source of light and the screen, that is capital D. This is the P point which is on the screen. This is the O, which is the center of this bright point. Suppose, consider this is the A and this is the B. So BP and AP, that is the path difference of the two waves. Means the waves which are emit from point A, the waves which is emit from point A, that is AP, and wave which is emit from point B, that is BP. So when wave OA and OB, that time which is bright, that is path difference is 0. So O point is the bright point. Means on the screen, the alternate dark and bright band which are formed on this screen. So in this screen, this is the screen P. So this screen P is the bright point. With that time, path difference, that is the BP minus AP, which is even multiple. This BP and AP which is even multiple. Same for constructive interference. In constructive interference, consider the point P, means this point P. In the medium, the path difference between the wave, which is reached at point P. At point P means this one. So in this case, this is A point, this is B point. So this A point and B point, this BP minus AP, that is the path difference. So that case, consider the point P in the medium, the path difference between the two waves reach at point P is BP minus AP. The point P will be bright. So point P will be bright if two waves, means this point P will be bright if two waves arrive at point P in the phase. That is, phase difference is 0, 2 pi, 4 pi, dash dash dash, 2 and pi. Path difference is 0, 2 lambda upon 2, 4 lambda upon 2, 6 lambda upon 2, dash dash dash, 2 and lambda upon 2. That is even multiple of half wavelength. That is even multiple of half wavelength. For constructive interference, BP minus AP is equal to 2n lambda upon 2. Means path difference is equal to even multiple of half wavelength, where n is equal to 0, 1, 2, 3. So in constructive interference, the maximum displacement of the wave is there. That time the phase, the waves which are in phase and the path difference is even multiple of half wavelength. This is the constructive interference. In constructive interference, the band or the point which is formed on the screen, that is the bright point. After that, destructive interference. Destructive interference. In this destructive interference, same diagram we have to refer here. Look at this diagram. So here, this is the A point, this is the B point, and this is the P point. This is the O point, same. These are the two sources, S1 and S2. The light which is emitted from this source, incident on the screen. So distance between screen and source, that is the capital D. Distance between two sources, that is the small d. And here point P, where we have to find out the point P is bright or dark. Destructive interference. In this destructive interference, if the two waves reaching at point P will be out of phase, then they will produce destructive interference. The point P will be dark when phase difference is pi, 3 pi, 5 pi, dash 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 2m minus 1 pi. And the path difference is lambda upon 2, 3 lambda upon 2, 5 lambda upon 2, dash 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 2m minus 1 lambda upon 2. That is odd multiple of half wavelength. For destructive interference, BP minus AP is equal to 2m minus 1 lambda upon 2, where m is equal to 1, 2, 3. Means in destructive interference, the waves which are reached out of phase and the path difference is odd multiple of half wavelength. That time this point P will be dark. In constructive interference, point P bright, and in destructive, which is dark. Next point, that is condition for producing steady interference pattern. Means to produce the steady interference pattern, means what is the conditions that are required. So which are they? The two sources of light must be coherent. What is the two sources of light must be coherent? The two sources of light must be emitting light waves of equal frequency and which are always in same phase or with a constant phase difference, are known as coherent sources. The two sources of light must be monochromatic, meaning having single wavelength. The two interfering waves must be in the same state of polarization. After that, the two sources of light must emit light waves of equal amplitude or intensity. And the next, the sources of light must be narrow. The separation between the two light sources should be as small as possible. The distance of the screen from the two sources should be large and the two interfering waves must travel in same direction. So these are the conditions for producing the steady interference pattern. After that, next point, that is the Young's experiment. In this experiment, this is the sunlight, S source of light. Look at this figure, this is the source of light. S is the source, the light which is emitted from this source S1, which is passed through these sources S1 and S2 in the form of slit. The distance between these two slits, that is a small d. The light emitted from these two slits S1 and S2 incident on this screen. These two waves emit which are interfere with each other and we get the result alternate dark bright band on this screen. This is the Young's double slit experiment. What is the importance of Young's experiment? It was the first successful experiment to show the interference of light waves. From this experiment, it is possible to calculate the wavelength of monochromatic light using formula lambda is equal to x small d upon capital D, where x is the fringe width. Fringe width means distance between two bands, dark or light band. That is the fringe width. Small d is distance between two sources S1 and S2, and capital D is the distance between screen and sources. This is the source and this is the screen. So this is the formula which we have to use to find out the wavelength of light. This is the again next diagram of this Young's experiment. So this means this is the S source of light. This slit S1 S2. The waves which are formed interfere with each other, means crest overlap with crest, trough overlap with trough, crest overlap with trough, and trough overlap with crest, and which forms the alternate dark and bright bands. So this is the Young's experiment. So thank you, student.